So we are going to see the implementation of Boolean function using logic gates. So how to implement the Boolean functions using logic gates. Okay. So first we are taking an expression, Boolean function or expression. F is equal to A B bar plus A bar B into C plus D bar. Okay. Now here the output is F, and you are having one, two product terms you are having, and here you are having a sum term. Sum term can be implemented by using OR gate, and product term can be implemented by using AND gate. Okay. Now we are going to implement by using logic gates. So here how many variables you are having? Four variables. That is A, you put an OR gate, so you'll be getting A bar. Then this is A, this is B, next to one C. C, and next to one is D. Okay, the shapes while you're drawing in your notebook, you draw it clearly. So since I am using the mouse, it is not clear. Okay, so I have drawn the four input variables and their complements. Okay, now the first term is A B bar. So this line is A. So we have to take one input from A. Next one is B bar. So this is B and this is B bar. So you have to take one input from B bar. Now what I am doing is I am giving it to an AND gate. Okay, give it to an AND gate. Okay, so this is the first term. Second, A bar B. So I am taking it from A bar and I am taking it from B. So I got A B bar. Next, what I am having is C plus D bar. What I am having? C plus D bar. So I have to take one from A and another one from D bar. But here the here the operation is plus. So you have to use a OR gate. Okay. Now the output of this OR gate and the output of this AND gate A bar B, that is another product. So we have to give these two outputs to a AND gate. Okay. Then this term and this product term you are making OR. So again you have to give it to a OR gate. Okay, this is nothing but your F. This is nothing but the F. Okay. So this is the expression A B bar. So this is first one is A B bar. This is A B bar. Next one A bar B. This is A bar B. And this is C plus D bar. This output is nothing but A bar B into C plus D bar. Okay. So this is the output of this AND gate. Then we have to add this output with the A B bar. So we are giving it to an OR gate, and we have got the output F. Okay, this is the implementation. Next, we are going for another example. Okay, F is equal to A bar B plus C into D bar. So here also you are having uh, four variables. Okay, it is better to take like this A, but you have to see another thing. The variables A and B and C is not having complements. Okay, the variable C and B is not having complements, so no need to use the not gates. So just you are having complements in A and D. So this is A, B, C, D. You are having complement, so you take A and you give it to an not gate. So you'll be getting. So first one is A bar B. So this is A bar and this is B. So this is a product term. So we have to give it to an AND gate. Okay. So output of this AND gate and C you have to add. So give it to an OR gate. Okay, fine. So output of this OR gate, we have to, this is D now. This is D. With the D bar, we have to product. So this is your final output F. Okay. This is the implementation of this Boolean expression. Now go to the another one. So here you are having three variables A, B, and C. So A bar, A here, then and this is C. Okay. Now first term is A bar, B bar, C. So you take from A bar, you take from B bar, you take from C. Okay, give it to an AND gate. Then A bar, B, C. A bar, B, C. Give it to an AND gate. Then A, B bar, C bar. A, B bar, C bar. Okay. So all these products are summed together. So give this output to an, give all these outputs to an OR gate. So you'll be getting F. Okay. So you'll be getting F. So this is a way of implementing your. So another implementation. Here also you are having four variables A bar, then B, B bar, C, C bar, then finally B, D bar. Okay. So A plus B. So you have to use a OR gate. You take one input from A and another input from B and you give it to an OR gate. Then C plus D bar. You take from C and D bar. You give it to an or gate. A bar plus B. This is A bar, then this is B. A bar plus B. And or gate. A plus B bar. You take from A, then from B bar. You to an R. So here all these some terms are ANDed together. So you have to give outputs to an you have to give this outputs to an AND gate. Okay. Give this outputs to an AND gate. So you're getting F. Okay. So this is a implementation. Okay. Good morning. Today we are going to see the Queen McCluskey method. So this is a subtopic of the main topic minimization techniques. So previously we have studied minimization using K-map. So the disadvantage of the K-map is when you are going for higher variables, 7 variables or 8 variable, it is so difficult to do, and the efficiency of that method depends upon how a person is doing that grouping. So in order to overcome this disadvantages, we are coming for Queen-McCluskey method or tabulation method. Now, steps for generating prime implicants in tabulation method or Queen-McCluskey method. So, the first step is list all the minterms in binary form. We have to list all the minterms in binary form. Second, we have to arrange the the minterms according to the number of ones. So depending upon the number of ones a particular minterm is having, we have to arrange. You have to arrange first. You have to arrange the minterm which is having no ones, that is 0. Next you have to arrange the minterm which is having only one ones. Then you have to arrange two ones. Like that you have to arrange. Then compare each binary number with the term in the adjacent next layer category, and if they differ by only one position, we have to put a check mark and copy the term in the next column with the x in the position that they differed. Now what we have to do is, after arranging the min term and depending upon the number of ones, we have to compare the row above should be compared with row below, and we have to take two minterms if they are differing by only one bit. Next is you have to apply the same process. Once again, you have to apply the same process. So next we have to list the all prime implicants, and finally we have to select the minimum number of prime implicants which must cover all the minterms. So while doing problem, we will clearly understand the steps. Okay, so the first thing is we have to write the we have to list all the minterms in binary form. Then we have to arrange the minterms according to the number of ones it is having. Then you have to compare the minterm which is um, in the above group with the minterm which in the below group, and you have to consider two minterm if they are differing only by one bit. Then you have to go for the same procedure for what we done in the step 3 for the next uh, uh, next pair. Okay, then next one is we have to list all the prime implicants, and then finally we have to select the minimum number of prime implicants which must cover all the minterms. Okay, directly we will go for a problem. So obtain, the question is obtain, question is obtain the minimum SOP using Queen-McCluskey method and verify it using K-map. So what we have to do is, first you have to find the minimum SOP using Queen-McCluskey, and you have to verify it using K-map. Okay. First, the question is F is equal to summation of M F is equal to summation of M 0, 2, 4, 8, 9, 10, 11, 12 and 13. The given question is in SOP. Since you are having summation here, it is in SOP. Now, in this question, the highest number is 13. To represent 13, you need how many bits? Minimum, you need 4 bits. So, you need 4 variables to represent these min terms. Or in other words, all the min terms should be represented by using 4 bits. So, the first step is we are going to convert this min terms into in binary. So first we have returned the min terms in binary. So this is 0 or 0, 0, 0, 0, 0. So if you want, you can write 8, 4, 2, 1. And we are converting this decimal to binary, that is 0, 0, 0, 0. Then we are writing 2, that is 0. So next we are going to write next we are going to write 2. 2 is 0, 0, 1, 0. Next we are going to write 4. That is 4 is nothing but 0, 1, 0, 0. Next we are going to write 8. 8 is 1, 0, 0, 0. So you write 8, 4, sorry, not here, here 8, 4, 2, 1. And you write the corresponding, here you can write 8421, you can write for 11, that is 8 plus 2 10, sorry, 8 plus 2 10 plus 1 11, so 1 0 1 1. For 12, 8 plus 4 is 12, 1 1 0 0. So you have to convert all these decimal to binary. Now you check here, 0 is having no ones, 2 is having 1 1, 4 is having 1 1, 8 is having 1 1, 9 is having 2 1, 10 is having 2 1, 11 is having 3 1, 12 is having 2 1. Next number is 13. 13 is 1 1 0 1. It will be having 3 ones. So next step is we have to write this number depending upon the number of ones it is having. So rewriting the numbers depending upon the number of ones in the min terms. So here you check 0, it is having no ones. So we have written the numbers which is having no ones, we have written. Then we have written, so first we have written 0, it is having no ones. Next we have written 2, it is having only 1 1. 4, it is having only 1 1. 8, on it is having only 1 1. After writing, so 0 is having no ones. So after writing that, you put a line. Then we have written the numbers having only 1 ones. We have put a line after that. Then we are writing the numbers having 2 ones. 9, 10 and 12 are having 2 ones. So we have written and we have put ones. Then we are writing the numbers having 3 ones. 11 and 13 are having 3 ones. So the second step is we have first we have converted that numbers decimal numbers into binary, and then we are writing the numbers depending upon the number of ones we are having. Now we are going for the third step. We are going to compare the numbers. So I will tell clearly the problem. So what you are doing is here this is the this table is nothing but rearranged numbers depending upon the number of ones. Now, what you have to do means you have to compare the number above the line with the number below the line. So, you have to compare the number below the line, number with number in the above the line with the number in the below the line, and you have to consider it only if they are differing by one bit. Now, you can take these two numbers. So, same. These two numbers, they are same. This is differing. So you put x here, it is differing. So this is same. So when comparing 0 and 2, they are differing by only one bit. So we can consider this. So it can be written as 0, 0, x 0. So the number what we have compared is 0, comma 2. For 0, comma 2, what we are getting it 0, 0, x 0. Now, in the animation, we will clearly know. First, we are going to compare 0 with 2. So, the green indicates the bits are same. This orange and blue indicates the bit is varying. So, only this bit is varying. So, it can be written as 0, 0, x 0. So, when comparing 0 to, we are getting 0, 0, x 0. Next, we are going to compare. First, we have compared 0 with 2. Next, we are going to compare 0 with 4. We have compared 0, we have finished 0 with 2. After that, we are going to compare 0 with 4. Same. These two bits are same. Here it is differing. So, you put an X. So, here it is same. Here also it is same. So for 0, so we can consider since there is only one bit is changing, we can consider. So 0, comma 4 is equal to, so this green indicates the bits are same, and this orange and blue indicates it is only a single bit which is changing. Now the expression for sorry, the 0 for while combining or comparing 0, comma 4, what we are getting is 0, 0, x 0. The place in which the bits are differing, there we have to put x. Next, we are going to compare. So, initially we have compared 0 with 2 and 0 with 4. Next, we are going to compare 0 with 8. Here also only one bit is changing. These three bits are same in 0 and 8, and only this bit is changing. So, you can write x 0, 0. So, you can write x 0, 0, 0. Next, you are going to compare 0. First, you have, okay. Now, please, now we have compared 0 with 2, 0 with 4, and 0 with 8. So, we have compared the 0 with all the numbers below this 0. The next step is we have to compare 2 with 9, 2 with 10, 2 with 12, then 4 with 9, 4 with 10, 4 with 12. Okay. Similarly, next we have to compare 8 with 9, 8 with 10, and 8 with 12. Similarly, you have to do. So next we are going to compare 2 with we are going to compare 2 with 9. So here more than one bit is changing. Here you are having, in the previous step we have compared 0 with 2, 0 with 4, 0 with 8, and we have considered the particular combination only if they are differing by only one bit. Now we have compared the min term above the line with the min terms below the line. So 0 we have compared with 2, 4 and 8. Now we are going to compare 2 with 9. Then we are going to compare 2 with 10. Then we are going to compare 2 with 12. After completing this, we are going to compare 4 with 9, 4 with 10, 4 with 12. After completing this, we are going to compare 8 with 9, 8 with 10, then 8 with 12. So now we are going to compare 2 and 9. 2 and 9 we are comparing. First bit, here you are having 0, here you are having 1. So one bit is changing. Here you are having 0, here you are having 0, no problem. Here you are having 1, here you are having, you take this as 1 bit is changing. Here you are having 1 and here you are having 0. So 2 bit is changing. So if more than one bit is changing, there is no possibility to consider that pair. So we are comparing 2 and 9. So the green, this orange and yellow indicates these bits are differing. So more than one bit is differing. So this 2 comma 9 combination is not considered. Next we are going for 2 with 10. 2 and 10 we are comparing. So here these three bits are same. The green indicates same bits are same. Here you are having 0, here you are having 0, here you are having 0, here you are having, here you are having 1, here you are having 1, here you are having 0, here you are having 0. Only this bit is getting changed when you are comparing 2 and 10. So while writing that expression, will be getting, since this bit is changing, in that place you have to put a x, x 0 1 0. You are getting x 0 1 0. So next you are going to compare 2 with 12. So when you are comparing 2 and 12, here 0, here 1, 1 bit is changing. Here 0, here 1, 1 bit is changing. More than 1 bit is changing, so we can't consider that. So more than one variable is changing, so we can consider that. So we have compared 2 with 9, 2 with 10 and 2 with 12. So 2 over. Now we are going to compare 4 with 9. Next we are going to compare 4 and 9. So when you are comparing 4 and 9, so here you are having 0, here you are having 1. 1 bit is changing. Here you are having 1, here you are having 0. So more than 1 bit is changing. Whenever you are getting more than one variable or one bit is changing, No need to take that pair. Okay, next we are going to compare 4 with 10. So here 0, here 1, one variable changing. Here 1, here 0, more than one variable changing. So we can't take that. Next we are going to compare 4 and 12. So the last three bits are same. So only one bit is changing. So we can consider. So we can write 4 comma 12 is equal to x100. X100. In which place the bit is changing, there you have to put x. In all the other places, you have to write the number what you are having. So next, we are comparing 8 with 9. So when you are comparing 8 with 9, only one variable is changing. So 100x. Next, we are comparing 8 with 10. Here also only one variable is changed. First two and last one are same, and only this variable is changing. So 8 comma 10 is equal to 10x0. Next, we are comparing 8 with 12. When you are comparing 8 with 12, you'll be getting only one variable changing. The second variable is changing. So 1x00. Now we have compared 2 with 9. We have compared 2 with 10, 2 with 12. Then 4 with 9, 4 with 10, 4 with 12. Then 8 with 9, 8 with 10, and 8 with 12. Now we are going to compare 9. Next step, we are going to compare 9 with 11, 9 with 13. Then 10 with 11, 10 with 13. Then 12 with 11 and 12 with 14. Okay. Now we are going to compare 9 with 11. So only one variable is changing. This variable is changing. All the other are same. Here first two same, and last one also same. So the expression is 1 0. This bit is changing. So x1. So next we are going to compare 9 with 13. So we'll be getting only the second variable here is changing. All the other are same. So you'll be getting 1x0 0. Next we are comparing 10 with 11. So only the last variable is changing. So 101x. So next 10 with 13. So when you are comparing 10 with 13, more than one variable is changing. Here you are having 0, here you are having 1. Similarly, here 1, here 0. So whenever you are getting more than one variable change, we can't consider that particular group. Then we are comparing 12 with and 11. So here also more than one bit is getting varied. So we can't consider that. Next 12 with 13. Only one variable, last variable is changing. So the expression is 110x. Only this one is changing and all the other are same. So you can write 110x. Next, after completing that step, we will be getting like this. So we have completed this the step 3. Next we are going for the step 4. Similar to the previous step, here also what we have to do is we have to check, we have to compare the line above with line below. So how this line is coming means, so you take the first one. So 02, 04, 08. Similarly, after completing this, you have to put a line. Then after completing 2 with 9, 2 with 10, 2 with 12, and 4 with 9, 4 with 10, and 4 with 12. After completing this, then 8 with 9, 8 with 10, and 8 with 12. After completing this, you have to put a line. Next is 9 with 11, 9 with 10, 9 with 9 with 11, 9 with 13, then 10 with 11, 10 with 13, 12 with 11, 12 with 13. After comparing like this, you have to put a line. Okay, now, similar to the previous step, we have to compare the combination above the line with the combination below the line. Here, in this step, what you have to do is you take the first combination. So you are having a x in the second place. Now you have to check here in any other position. So in the below this line, you are having x in the same position. So here you are having x. Now you have to check whether you are having x in the same position below that line, but above this 911. So in this area, you have to check whether you are having x in the same position like that, in the second position. So here you are having an x. Now we have to check whether these two, that is this 0, 4 and 8, 12 are differing by only one bit. Here you are having 0, here you are having 1. So 1 bit variation. Here you are having 0, here we are having 0. Same. So here 0, here 0. Okay. Now 0, 4 and 8, 12, they are differing only by 1 bit. And the expression is 1, here it is varying 0, 4. So it is x, x, 0, 0. Next you have to check here. So you are having x in the first position. Now you have to check in this area whether you are having x in the first position, and they have to differ by only 1 bit. So you take 0, 8 and 2, 10. You take here x, no problem. Here 0, no problem. Here 0, no problem. They are differing only by 1 bit. So you can write like this: 0, 8, 2, 10. First one same x, second one same 0. Next one is changing x, then 0. Similarly, you are having another x here. So you are having x here and you are having another x here. Now we will check whether they are differing by 1 bit. Here no problem. Here differing by 1 bit. Here same. Here same. So it is nothing but 0, 8, 4, 12. So we will be getting x, x, 0, 0. So there is no another one you are also having. You are having x here also. Now these two, so already we have compared that, so no problem. Similarly, you have to go for the next step. We will clearly see in the next slides. Now first we are going for 0, 2 and 8, 10. To do is you have to compare this pairs with the pairs which is below the line. You have to compare the numbers above the line with the numbers below the line. So here what you have to do is, first you have to check, first you consider the number 0, 2. In the 0, 2 you are having a x in the third position. Now you have to check whether you are having any x in the same position in this area only, that is below this 8 to 10. So while checking like that, you will be getting AX here. Now you have to check whether they are differing by 1 bit. So here 0, here 1. It is differing by 1 bit. Here 0, here 0, same. Here 0, here 0, same. So we can consider 0, 2 and 8, 10. And first bit it is differing. So X, second one 0, then next one x, next one 0. So this is a thing what you are getting. So we'll see in animation. So we are going to compare 0, 2 and 8, 10. So we are checking the position x. Both are having x in the same position and they are differing only by 1 bit. In this 1 bit only it is differing, and all the other same are other things are same. Here you are having same, 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 and it's what you are getting means x0 x0. So the expression what will be getting is x0 x0, because uh, first variable it is changing, the first term it is, or first digit it is changing. Here you are having 0 and here you are having 1, so we have put it a x. Next one same, next one x same, next one 0. Okay, so similarly we will be comparing. Next we have compared the 0 2 with 8 10. So we have compared 0 2 and 8 10, and by checking that we are having only the first bit is differing, and while writing you will be getting 0 to 8 10. This is a prime implicant. 0 to 8 10 is x0 x0. Since the first bit is changing, we are writing it as only the first bit is changing, so we are writing it as x. All the others are same. 0 x 0, 0 x 0. Okay, next we are going to compare. Next we are going to check the second one, 0 4. In 0 4 you are having x in the second position. Now we are going to check whether we are having x in the similar position below that line, below this line up to here. We are checking whether we are having x in the same position. So here you are having x. Now we are checking for 1 bit variation. Here you are having 0, here you are having 1. So 1 bit is varying. These two are same, these two are same. So we can consider 0 4 8 12. So in animation we will check. So we are comparing 0 4 and 8 12. So only the first bit is changing. So we'll be getting xx 0 0. Okay. Now we are going for the next one, that is 0 8, and we are comparing 0 8 and 2 10. So first this x we have checked, here you are having, and we have taken. Next this x we have checked. Now we are going for the third one. So now we are checking whether we are having x in the first position. So here you are having the first position, and then we have to check whether they are differing by only 1 bit. So it is differing only by this bit. So x0 x0. Okay. So 0 8 2 10. Now then we are going to compare this group with this group, that is above this line, the numbers above this line with number below this line. So when you are first you consider this 210. So you are having x in the first position. Whether you are having any x in the first position here, no. So we no need to take this one. Next also 412 x in the first position. Here we are not having. So now you take 8 9. So in the 8 9 you are having x in the last position. So here also you are having x in the last position. Now we have to check whether they are differing by only 1 bit. First bit is same, second bit is same, only the third bit, only 1 bit is differing. So 10xx. So 10xx. So when you are comparing 8 9 and 10 11, you will be getting 10xx. Only this is varying. So this is a prime implicant what you are getting. Okay. Next you are comparing 8, 9 with 12, 13. So already I have done. Here you are having x, here you are having x, and only this variable is changing. So it is 8, 9, 12, 13. Okay, 8, 9, 12, 13. Okay, now then you are comparing 8, 12 with, so here also x in the second position, here also you are having x in the second position, and they are differing by only one bit. Okay, okay, this only one bit is changing. 8, 12, 9, 13. Okay, next you are comparing 8, 10, and 9, 11. So here also it is differing only by one bit. So while writing the prime implicant, 8 and 9, 11 is equal to 1, 0, xx. So after that, we have to list the prime implicant. So this is the prime implicant what you have got in the step 3, and these are the prime implicants what you get in the step 4. Now in some cases you will be getting the same prime implicant. For example, 0, 2, 8, 10 will be 0, 2, 8, 10 is will be equal to some 8, 2, 8, 0, 10, like that you'll be getting. So you'll be getting the same prime implicant. If you're getting in simple, I will tell, if you are getting the same implicant two times, you have to consider it only once. Okay, if you are getting the same implicant, for example, if you are getting the same x0 more than once, you have to take only one time you have to take. Now next step is, after getting this, we have to go for the next procedure. You have to find the prime implicants. So here you are having 0, 2. This 0, 2 is present in this prime implicant also. So you have to tick it. Then 0, 4. 0, 4 you are having here also. So you have to tick it. 0, 8 you are having here. So you have to tick it. Then 2, 10 you are having here. So you have to tick it. So 4, 12 also you are having. 8, 9 you are having. 8, 12 you are having. 8, 10 also you are having. 9, 11 you are having. 9, 13 also you are having. 10, 11 you are having. 12, 13 you are having. So the prime implicants present here, it is also present in these sets. Okay, so no problem, we will go for the next step. So if some prime implicant is missing, so in problems some prime implicant will be present here, but some prime implicant will not present in this sets. So if some prime implicants is not present in this set, and if it is present here, then you have to consider that prime implicants also. Okay, now next we are writing the prime implicants. These are the prime implicants. From this prime implicants, we have to find the essential minimum number of prime implicants. Okay, from this we have to find the minimum number of prime implicants. In order to find the minimum number of prime implicants, we have to draw a table. This table is nothing but the first column is, we have to take the prime implicants we got in the previous step, and this is nothing but the min terms what we have got in the question. So 0, 2, 4, 8, 9, 10, 11, 12, 13. These are the min terms that is present in the question. These are the prime implicants what you what you're getting after doing step 5. Now The first prime implicant is 8, 9, 12, 13. This 8, 9, 12, 13 is similar to the quad what you are getting in K-map. Okay. The 0 to 8 one is similar to the quad what you are getting in the K-map. Now, in the place of 8, 9, 12, and 13, you put stars. 8, 9, 9, 12, 13. Okay. Similarly, 0 to 8, 10, then 0, 8, 4, 12, then 8, 9, 10, 11. So you put stars. After that, you have to you check each and every column. If any particular column is having only one star, you put a tick mark corresponding to that row. So first column it is having 2 star, neglected. Second column it is having only 1 star, so you put a tick mark. So here I have put a, you put a tick mark to the this corresponding row. Next, here you are having only one tick mark in this column, so here you put a tick mark. Then here 3, here 2, here 1, already we have put tick marks. Here also you are having only one star, you put a tick mark. Then here also you are having 2 stars, here you are having only 1 star, so you put a tick mark. So all the prime implicants are get ticked. It 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 states the meaning of this is we have to consider all these prime implicants, and all these prime implicants are these are the minimum prime implicants, and there is no redundant prime implicant present here. So the step is what you have to do. First you have to write the prime implicants like this. Then you have to in the rows you have to write the sorry, in the columns you have to write the min terms. Then you have to put star in the corresponding boxes. Then after that you have to check each and every column, and you have to put a tick mark correspond in the corresponding row if you are having a single star. If you are having a single star in a particular column, if you consider the second column, here it is having only 1 star, so you have to put a tick mark. So similarly in the this column here you are having only 1 star, so you have to put a tick mark. So in this problem all these prime implicants are get ticked. So these are the minimum prime implicants. So now we have written 0 to 8, 10. So we have got x0, x0. For 0, 8, 4, 12, xx, 0, 0. For 8, 9, 10, 11, 1, 0, xx. For 8, 9, 12, 13, 1x, 0x. So next, what we are doing is, so we have put this variables a, b, c, d over that. So if x is there, no need to consider that particular variable. If 0 is there, you have to complement that variable. If 1 is there, you have to uncomplement that variable. Now we are going to write the expression. So for 0 to 8 to 10, a is x, no need to consider. B 0, so b bar. C is x, no need to consider. D is 0, so d bar. Similarly for 0, 8, 4, 12, 8 for 8, 9, 10, 11, and 8, 9, 12, 13. After getting these terms individually, you have to add these. So this is the answer. So this is the answer for this problem. Okay. So after that, we have to, by using K-map, we have to verify whether we are getting the same answer. We will get the same answer. Okay. This is the first problem of Queen-McCluskey. Okay. Next, we will see the next model. So these are the minimum prime implicants. So the next problem is obtain the minimum SOP using Queen-McCluskey method and verify using K-map. Okay. Now the problem is in SOP, and the given minterms are 3, 4, 5, 7, 9, 13, 14, and 15. First, what we have to do is we have to write these numbers in binary. So since we are having 15, we need 4 variable to represent. So we are writing all the minterms by using 4 variables. Then what we are doing is we are writing depending upon the number of ones we are having. So Here we are not having 0. So first we are writing the minterms which is having only 1 once. Then we are writing the minterms which is having 2 ones. Then we are writing the minterms having 3 ones. Then we are writing the minterms having 4 ones. After that, we are going for comparison. So the comparison is we are going to compare. Now we are going to compare 4 with 3. So the first variable is same, second variable is changing, third variable is changing, and fourth variable is changing. Here more than one variable is changing. So we can't compare, we can't consider 4 and 3. So next we are going to compare 4 and 5. When you are comparing 4 and 5, only one variable is changing. So we can consider only the last variable is changing. So what you are getting is 0, 1, 0.